What's a confidence interval? We said before that the sample mean was an estimator for the population mean, and the sample variance was an estimator for the population variance. What's the probability that the sample mean is equal to the population mean?
Under the last number, will for the value of the population mean.
So X is a random variable with finite mean and variance. And the mean happens to be mu. And I come to you and I say, what's the probability that X bar minus mu is equal to 0? You know the answer to that? Turn the volume up. You have to speak more loudly. Van says that probability is 0. Everybody agree? Yeah, because what's the probability mass over a point? 0. So chronologically, that's true. Which now really has JJ confused. Right? Because before I was telling you that the sample mean is an unbiased statistic. On average, it's equal to the population mean. And now I'm telling you the probability that the sample mean is equal to the population mean is 0. What in the world is this guy doing to us? So when do we use confidence? If the point estimate is always wrong. Always wrong. What good is it?
Interval estimate.
JJ, watch out, he's stepping on your toes here. He's trying to steal your 10 points.
Well, you mentioned my name.
So JJ says that because the point estimate is often wrong, is always wrong, we want to have an interval estimate. So Juan Chen, now he's really backed you into a corner because now you're stuck telling me how to construct the confidence interval for the population mean. Yeah.
Like normal distribution.
Okay.
So first, we know the standard normal distribution and know the local function and and then we
Okay. X is normal distribution. Where X is squared. And I'm asking you to construct a 95%. Let's do it this way. Let's do it a 1 minus. I want you to tell me what to do.
we want to estimate the x bar with the x bar minus over mu.
You don't know me.
Mu of x bar we can get from sample.
Yeah.
And mu is the what we want to estimate.
Okay.
So we want to use larger than or bigger than
That was you're trying to do, right? That's what you're trying to do, right? Right. Okay. I hope I wrote it right. Is that what you wanted to do, right?
Yeah.
No, you have all the notes in front of you. I may have got it wrong.
I don't know. This is the S over.
Where were they? You don't know? But we said that X, we said that X was at normal. Right, when T is set.
What goes wrong with that?
Because it's next to it in the alphabet? confidence interval for the population mean. It just so happens that I did this. I collected a sample of several students and I weighed them all. And I used this technique, and it turned out that the 95% confidence interval that I constructed gave me the result that that's my 95%. That's the 95% confidence interval I got out of my sample data. Okay. And I said 95%, right? Is that correct? Why not? Is that statement that I wrote at the bottom left of the board correct?
Correctly use 141
It should not be. How do you know that? Weren't you the one that told me to write the probability of x bar minus t s over radical n is less than or equal to mu is less than or equal to x bar plus t times s over radical n is equal to 1 by itself? You told me to write that, correct? So you and I negotiated. That's true. And then I told you I took a sample of some size n. I don't know what it was. Size. And to the left, the number that I got for the calculation to the left of the inequality was 141, and the number that I got for the calculation to the right of the inequality was 176. And I said if I got those numbers, then I ought to be able to write the probability that mu is between 141 and 176, and equal to 95%. True or false? Huh. I'm not sure I understood the question, but x bar minus t alpha over 2 s over the square root of n is equal to 141, and x bar plus t alpha over 2 s over the square root of n is 176.
Yeah.
So you agree with this?
Yes.
Everybody agree with 110? Raise your hand if you agree with 110. I'm going to have to write fast depending on who raises their hands or not. You got to vote. This is election day. We're skipping the election. Who agreed? Raise your hand up high enough so that I can see it. 19 people. About almost 50% of the class. So the yeses are 19. The no's are who said no. She's not correct. 8.